All right, folks, take two after recording that and not saving it properly. So we have here, we're going to explore our compound angle formulas, and that is we're going to learn about creating compound angles, working with them, and how to use the formulas. We won't derive the formulas themselves today. Now, we're all familiar with our special triangles and the angles that are involved. The angles that are involved in the special triangles are all written here. That is pi over 6, pi over 4, pi over 3, and pi over 2. Now, a compound angle, we can use these angles to create a compound angle. That is, it's created by adding or subtracting two or more angles. Usually, you use the special angles. In our case in this course, yes, we're going to be using the special angles almost all the time. Not all the time, but almost all the time. All right, so that is, we're going to work to create these angles by only adding and subtracting those angles up there, that is, the special angles. So if we work with pi over 12, well, pi over 12 is a nice and easy one. If we work with pi over 12, that is, we can have pi over 3 minus pi over 4. And you might say, well, hang on, I'm not positive that equals pi over 12, so we can double check it, right? Pi over 3, that's like 4 pi over, 12. Pi over 4, that's like 3 pi over 12. And 4 pi over 12 minus 3 pi over 12. Grade 5 math skills tell us we're working with pi over 12 right here. So as a compound angle, pi over 12 can be written as pi over 3 minus pi over 4. Now, that might not even be the only method. If we have pi over 12 here again, we can work with it. Okay, well, pi over 12, that's like pi over 4 minus pi over 6. And you might say, well, hang on, I'm not positive on that. Let's double check. Okay, well, pi over 4, that's like 3 pi over 12 minus pi over 6, that's like 2 pi over 12. Lo and behold, 3 pi over 12 minus 2 pi over 12, that equals pi over 12. So another way to create pi over 12 as a compound angle is pi over 4 minus pi over 6. All right, well, let's go further. 5 pi over 12. Again, I encourage you, pause the video here, try it out before we go through it again. 5 pi over 12, that is, we're working here with pi over 4 plus pi over 6. And if you're not sure on that, that is 3 pi over 12 plus 2 pi over 12, bringing us to 5 pi over 12 like we need. Okay, so this should be pretty straightforward at this point. You should be able to handle a couple more. We have 7 pi over 12. Okay, that one has nothing special to it. 11 pi over 12, here we're starting to get into a little bit more. 7 pi over 12, that answer was pi over 3 plus pi over 4. I paused there a little bit to give you the chance to pause the video. 11 pi over 12. Okay, so we're working with here. That is pi over 2. Plus, well, frankly, pi over 12, that's like pi over 2 plus pi over 5. Sorry, plus 5 pi over 12. Well, 5 pi over 12, that's like pi over 4 plus pi over 6. So 11 pi over 12, that's pi over 2 plus pi over 4 plus pi over 6. Now, this is all well and great, but we can write this a little bit better. And that is, we can write it as only as only a combination, adding or subtracting, of two special angles, or, and here's the key, or multiples of these special angles. So we'll work with pi over 2 and pi over 4 right here. Well, pi over 2 and pi over 4, we'll work with pi over, and I was right the first time, we'll work with pi over 2 and pi over 4. Okay, well, pi over 2, that's like 2 pi over 4. Pi over 4, that's obviously like pi over 4. And all of a sudden, you see where we're going to go. 2 pi over 4 plus pi over 4, that equals 3 pi over 4. Sorry, I got a little bit lazy there. I left my pi over 6 up above in blue. We'll bring that down, plus pi over 6 plus pi over 6. So that is 11 pi over 12 is equal to, and I'll rewrite that, 11 pi over 12 is equal to 3 pi over 4 plus pi over 6, where it's written as two angles. Are they both special angles? No, but they're both multiples of special angles, and it's the multiples of special angles that we already know how to work with in trigonometry from our cast rule. Now, here is the first time you're seeing, I believe, your double angle formulas. Now these double angle formulas, they might look pretty complicated. We're not going to derive them in here. It's not worth our time. But if you're looking for a derivation, you can check page 394 from the textbook, or you can look at the University of Waterloo's OpenCourseWare, where they go through each of these derivations. Now, if you're in my class and regardless of the year you're taking this, you will be given these formulas on assessment. So you do not need to memorize these formulas. It's not worth our time. It's only worth our time to practice these formulas themselves. Now, if we're practicing these formulas, let's take a look. We're working with the cosine of 7 pi over 12. You might recognize 7 pi over 12. Okay, what is that? That is certainly not a special angle. That is not an angle that appears in our special triangles, and it's also not a multiple of a special angle. It's not an angle whose related acute angle is in our special angles. This, previous to this lesson, was an aberration. This was an angle that you did not have the skills to handle. Luckily, now you have them, given these 6 equations here. So if we're working with the cosine of 7 pi over 12, thanks to our newfound skills, 7 pi over 12, what's that? Well, that's pi over 3 plus pi over 4. So we'll work with that here. So that is the cosine of 7 pi over 12 is equal to the cosine of pi over 3 plus pi over 4. Bear with me here while I color code this. Pi over 3 plus pi over 4. Now, this pi over 3 plus pi over 4, what we're working with here, we notice it's a sum of 2 angles within a cosine function. Well, the sum of 2 angles within a cosine function, one of our compound angle formulas listed above, is also a sum of 2 angles inside a cosine function. Which one is that? I'm hoping you found it by now. It's formula 3, where we're working with a cosine function right here, and we're working with 2 angles adding together, that's here and here. All right, so we're working with equation 3. Equation 3 tells us that the cosine of x plus y is equal to the cosine of x times the cosine of y minus the sine of x times the sine of y. So we'll work exactly with that. And that is the cosine of x, in this case x is our pi over 3, times the cosine of y. Well, in this case, our y is pi over 4. And bear with me, folks, as I go through color coding this. I do think you will find it handy. I know some of my other classes did. Minus, and you can refer to, minus here, the sine of x times the sine of y. The x, again, x here is pi over 3. Now, does it matter which one is x and which one is y? At this case, absolutely not. X plus y, it does not make a difference. If you're working with x minus y, all of a sudden it's going to make a difference. So you'll need to be a little bit careful there. All right, so the sine of pi over 3 times the sine of pi over 4. Now, you'll notice here, yes, this might look more complicated. This is 4 pieces. The first one only had a trig function in there once. But you'll notice the cosine of pi over 3, oh, we already know how to evaluate that. The cosine of pi over 3, all we need is a special angle, right? Where this is side length 2, side length 1, the side length square root 3. Where we have pi over 3 in the corner right here, pi over 6 up there. We don't really care about that because we're looking for pi over 3. All right, well, pi over 3, the cosine of pi over 3, that is the adjacent side divided by the hypotenuse. Well, the adjacent side of pi over 3, we're working with 1. The hypotenuse, that's 2, so we're working with 1 over 2. All right, well, the cosine of pi over 4. Do we know how to evaluate that? Yes, absolutely. All we need is a special triangle. Which special triangle? Not this one. We need one that has pi over 4. So we quickly sketch that out. Remember, these are parts of your solutions here. So you would need to include them anytime you're working like this. So we're working with pi over 4. The adjacent side over the hypotenuse of pi over 4, that is 1 over the square root of 2. All right, now we're working with the sine of pi over 3. Well, the sine of pi over 3, that's the opposite side over the hypotenuse for, again, pi over 3. We're working with the square root of 3 over 2. You'll notice I'm going super quickly through this right here, and that's because we practiced this. We learned about this in chapter 6. The sine of pi over 4, that's 1 over the square root of 2. Okay, so we're working here. We have 1 over 2 times 1 over the square root of 2. So we can multiply these fractions together. We're working with 1 over 2 root 2. Okay, and then we're subtracting, and we can multiply these fractions together as well. We're working with the square root of 3 over 2 root 2. Well, luckily, both of our fractions already have a common denominator, so we can combine them into one fraction. That is 1 minus the square root of 3 divided by 2 root 2. Now this is all well and great. We're all finished as long as you're in grade 11 math. The problem is we're in grade 12 math. So what we need to do is rationalize this denominator. Right down here, since there's a square root in it, we need to manipulate the expression so that it no longer includes a square root. So how can we do that? Well, we can multiply the denominator by the square root of 2. Sorry for my art right here, by the square root of 2. And if we're multiplying the denominator by the square root of 2, we need to multiply the numerator by the square root of 2. If we just write it in like this, that's not good enough because that just multiplies this term by the square root of 2. We need to multiply the entire numerator by the square root of 2. All right, when we're simplifying this, we're working with, we're working with the square root of 2 minus the square root of 6, all divided by 4. There you are. You should be able, I'm hoping you were able to follow every single step involved there. Now, if you were able to handle every single step involved there, pause the video, try out 2b on your own, and then unpause it where you'll have the final answer. Final answer coming in 3, 2, and sorry folks, I know included on your copy, but was not included on my copy until I just added it in, was that pi beside the 11 right here. But we have here the final answer. You'll notice I have jumped a step here as we're simplifying. You should be able to handle that on your own just fine. All right, well, let's look forward to 2c. Well, when we're working with 2c, all of a sudden we're working with a different compound angle formula. How do I know that right away? Well, because this time it says tangent, not the cosine of our angle. Here again, we're working with 7 pi over 2. We just worked, 7 pi over 12. We just worked with 7 pi over 12, so I'm going to go through that pretty quickly. That is, this is equal to the tangent, don't forget to write that part in, of pi over 3 plus pi over 4. Okay, well, the tangent of pi over 3 plus pi over 4, we know we're working with a compound angle formula that has tangent involved, and we know we're working with a sum, not a difference, and that is we're working with addition, not subtraction right here. And if that's the case, then we're working with equation 5 up here, the sum of a tangent function. Okay, the sum of two angles of a tangent function. Now you have this note in front of you, so I'm not going to keep it on my screen as I go through. You know what? No, I won't. And I have it in front of me as well. So if we're working with the tangent of x plus y, and that is pi over 3 plus pi over 4, that means we're working with the tangent of x, and that is the tangent of pi over 3, plus the tangent of y, and that is the tangent of pi over 4. And we're dividing that by 1 minus the tangent of x, and that is the tangent of pi over 3, times the tangent of y, and that is the tangent of pi over 4. Well, if we're going to evaluate the tangents of pi over 3 and pi over 4, and those are the only ratios that we're working with in here, then what we need are our special triangles. So we can work here with 1, 1, the square root of 2, pi over 4 in this angle here, pi over 4 up there as well. We need the other special triangle. Okay, we should be able to draw it very quickly at this point. 2, 1, square root of 3. We're involved with the right angle here. Pi over 3 is the big one. Pi over 6 is half of that. And we're working with the tangent of pi over 3. Okay, the tangent of pi over 3, that's the opposite over the adjacent side. Again, I'm going really quickly because this is from section 6.2. The tangent of pi over 3, we're working with the square root of 3. Okay, the tangent of pi over 4, there we're working with 1. So square root of 3 plus 1, all divided by 1 minus, again, the tangent of pi over 3, and that is the square root of 3 times 1. All right, if we're simplifying something like this, nice and straightforward, I'll just rewrite that slightly differently, 1 minus the square root of 3. Then we need to check and ask ourselves, okay, is this a grade 12 level solution? And hopefully pretty quickly you can see, no, it's not. We have a rational in our denominator. We must rationalize our denominator, a rational term. So if we're doing it here, you might notice it's not as simple as last time. We're not able to just multiply the denominator by the square root of 3. In this case, because there are two terms in the denominator, if we're going to rationalize it, then what we must do is multiply both the numerator and the denominator by the conjugate. And I know you've seen that term before. I'll refresh it for you if you don't remember. By the conjugate of the denominator. Now, if we're working with the conjugate, well, the conjugate of a plus b is a minus b. All right, the conjugate of a minus b is a plus b. So if you're working with the conjugate, then you can take the absolute value of both terms and you take the second term and change the sign. If it was negative, it becomes positive. If it was positive, it becomes negative. So if we're multiplying by the conjugate here, then what we need to work with, and let's go with a better color for conjugate. What we need to work with in here is 1 plus root 3. Now, what we're multiplying by that is the entire denominator, so it's going to need some brackets here. If we're multiplying the denominator by that, we need to multiply the numerator by that as well, by the same thing. Not the conjugate of the numerator, just the same conjugate that we worked with in the denominator. And again, we need brackets. Now, when you're simplifying this, I'm not going to show every single step, so you can get a little bit of practice here. When you're simplifying this, make sure you're working with your FOIL first in your numerator and your FOIL in your denominator, and then you simplify. It should simplify, and I'll give it a jagged line to show that there are some steps missing here. It should simplify to negative 2 minus root 3. All right, you could show that slightly differently if you want to show negative and then brackets if you want to factor out the negative 1, but either way, you should be able to handle that there. Lastly, example 3. Now, example 3, I'm not going to spend my time going over the whole thing, but I will get you started. Okay, example 3 tells you to verify that an equation is true. Well, if this equation is true, that's great. But if we're verifying it, we're not able to assume the equation is true. So we need to, you guessed it, split it up into its left side and right side. When we're splitting it up into its left side and right side, we always have to show that first step exactly copied from up above. So our right side, what is that? Well, that is negative the tangent of theta. All right, our left side, what is that? Our left side is equal to the tangent of 2 pi minus theta. And the hint I'll give you here before I keep going, before I end the video, the hint I'll give you is that we're working with the tangent of a difference over here. So you're going to need to use one of your compound angle formulas, and it's going to have to include the tangent function and a difference of two angles right there. So try it out on your own. The full solution is posted on the classroom. Good luck, and you should be able to handle the homework from this point forward.